All right, scholars, another important formula that you have to have memorized for the whole year, besides just the midpoint, is the distance formula. And we always know that distance has to be positive. We already talked about that with our Ferris Bueller video. And it's always fun for me to see that clip because it brings me back to my teen years. Not that I can overly recommend that movie for you, but if you want to watch it, talk with your parents. It's a fun video to watch about in the teen years. But the distance formula, first of all, I'm going to tell you right now, we'll derive it later in math and talk about why it works. But the distance formula is really based off of the fact that I can use the Pythagorean theorem to solve for the distance between 2 points. And we use it for when we have a coordinate plane. Notice what we have here. Do I still have point 1, which is x1, y1, and point 2, which is x2, y2? Yes. And then I'm going to plug it in to get my values. But basically, I find the difference of the x's to find one leg. I find the difference of the y to solve for the other leg. So it looks something like this. x2 minus x1 squared plus the quantity y2 minus y1 squared, all taken the square root of. Please don't take the square root of those individually. You have to wait till the whole thing is done in the process. So when you do it, you have to know how to label and you have to know how to work out with your radicals. You might want to have your calculator handy. There's going to be some things I'm going to really assist upon that you don't do wrong. So notice here, these are slanted. A lot of times it's a lot easier just to go ahead and count the length if they're horizontal and vertical. But when I have the distance formula, I want to make sure I'm using it. So I'm looking for the length or distance between points FG. So if I'm looking for the length of segment FG, I have my ordered pairs. So I know this one is 1, 2, and the ordered pair for this one is 5, 5, I do believe. Now, label your points. I'm going to let's see if I can find a red pen here to help me out. This is going to be point 1, and these are going to be point 2. You can flip-flop these around because when you square things, they come positive, so it's okay to do. And then I'm going to plug it in. Let me squeak the formula in right above here and it give my enough. I'm going to actually use white out because I can't stand the fact that doesn't look good. This is the perfectionist side of your teacher, not wanting it to look bad when you're doing it. Let's write our formula down for the length of segment FG. The formula is x2 minus x1 squared plus the quantity y2 minus y1 squared, the whole thing taken the square root of. So then I plug it in. What was my x2? Well, my x2 was 5. So I go 5 minus x1, which is 1, squared, plus the quantity y2, which is also 5, minus y1, which is 2, squared. Now, order of operations say I have to go inside the parentheses first. So that's going to be 4 squared. That ended up being 3 squared. And then order of operations say I have to do my exponents next. Notice it didn't say take the square root of each of them next. That doesn't work. It's not the same thing. This is going to be 16 plus 9. Then order of operations says we have to add or subtract. So that's 25. Then I take the square root of 25, which is 5. So the length of segment FG is 5 units long. Now that's not hard to do, but unless you do something wrong. Like for instance, taking this one, the value of square root of 25 is 5. It is not the same thing as going the square root of 4 squared plus the square root of 3 squared. That ends up being 4 plus 3, which is 7. Notice, not the same value. Make sure you use the right operation. So now we're going to do the same type of process for segment JK. Okay, so when we do that, I got a runny nose today, so this is like been driving me crazy while I'm teaching this. This is going to be point -4, 0, and this is going to be at point -1, can't say that very well, -3 points. Here's point 1, here is point 2. I'm still going to write my formula down for the distance between the 2 points J and K, or the length of segment JK. So we get our x2 minus our x1 squared, our y2 minus our y1 squared. What's x2 going to be here? It's a -1 minus x1, which is a -4, parenthesis happy, remember, plus the quantity y2, which is a -3, minus, again, y1, which is 0, squared. So subtracting a -4, that's a +4. So -1 plus a +4 is 3. So that's really 3 squared. -3 minus 0 is a -3 squared. So I get 9 plus 9, that's the square root of 18, which reduces down to the radical 3 root 2. Now I think your book might let you go to the nearest tenth when you work with these, so it's approximately 4.2. However, I prefer this because that's the exact answer. So if you're going to do the decimal, try to get the exact answer first. Some of you don't remember how to do this from Algebra 1, so just read directions. If they say the nearest tenth, great. If you can do it with doing very specifically with radicals, even better. Now, if it says go to the nearest tenth, go ahead and do that, and then you can use your calculator to help you figure it out. So let's get this last distance formula calculated. And I'm laughing here because I think I have the thing repeated twice in my notes. So we're going to go here where we have a little bit more room when we're doing this. Now ask me why I have this twice on the notes. I have no idea. But let's go right here to where there's information. I want to find the distance formula between D and E. So that's the length of segment DE. Let's let this one be 0.1. And let's let these be 0.2. Okay? We're going to write our distance formula out for that line segment. So x2 minus x1 squared plus the quantity y2 minus y1 squared. Plug and chug directly below. x2 is a -2. x1 is 3, so minus 3 squared. y2 is a -5 minus y1, which is 4 squared. That gives me a -5 squared plus a -9 squared. Well, that's 25 plus 81. And so then I get the square root of 106. And the cool thing is, I know that's not a perfect square number, so when I punch this into my calculator, and by the way, there is nothing else that simplifies into, that's actually simplest radical form, I get approximately 10.3 when you punch it into your calculator. So hopefully this will help us get going on this, and we'll get a few more ideas.